Here's an example you're asked to solve. Minus 6 secant squared x minus 16 secant x equals 10. And you were asked to solve or find all solutions on the interval 0 to 2 pi. First thing I'm going to do is move everything over to one side. So I'm going to get a 6 secant squared x plus 16 secant x equals, plus 10 is equal to 0. This is a quadratic formula. To make it a little easier, I see that everything is divisible by 2. So I'm going to divide by 2. And I'm going to get 3 secant squared x plus 8 secant x plus 5 is equal to 0. You notice this is of the form 3u squared plus 8u plus 5 is equal to 0. The question is, can we factor that? This looks like a quadratic formula, and so I'm going to guess and check. I know I need a 5 and a 1 on the end, and I have a 3u and a u. Let's guess this. I know that 3 plus 5 is 8, so I'm going to guess a 3u plus 5 times u plus 1. 3u times u is 3u squared. 3u plus times 1 is 3u. 5u, that will give me my 8u, which I need, and then my last, which is plus 5. So yes, this is the right guess for my quadratic formula. Let's put it back in terms of secant. Thus, I get 3 secant x plus 5 times secant x plus 1 equals 0. And remember, when we solve these, either this one equals 0 or that one equals 0. Let's do this one first. I get secant x plus 1 is equal to 0. So secant x equals negative 1. And remember that secant is 1 over cosine x is equal to negative 1. And if you would flip and multiply, or however you want to do it, you get cosine x is equal to negative 1. Therefore, x is going to be equal to cosine inverse of negative 1. Where is cosine theta equal to negative 1? If you remember your unit circle, that is right here at x equal to pi, which is 3.141592, or rounded off to 4 decimals, 3.1416. That is one solution. Now let's find the second solution. We have 3 secant x plus 5 is equal to 0. 3 secant x, subtract the 5 from both sides. So you have 3 secant x equals negative 5. Divide by 3. And you have secant x is equal to negative 5/3. Again, secant is 1 over cosine x. And you can cross multiply, flip and multiply, or whatever, and you'll get cosine x is equal to negative 3/5. Therefore, x is equal to cosine inverse of negative 3/5. On your calculator, you can plug this in. Make sure you're in radian mode because it did ask for the solution in radian mode. You will get one solution that x is equal to 2.2143 radians. Now, the problem with this is that there are two solutions. Remember, the inverse function gives you an angle in the restricted domain. The restricted domain for cosine is quadrants 1 and 2, and so it has given us this angle here. This x is equal to 2.2143 radians, which is approximately 126.9 degrees. The problem is there is a second angle in quadrant 3 where cosine is also negative. It's this angle here. How do we find that? This is pi radians. I'm going to call this alpha. And if we reflect across from quadrant 2 to quadrant 3, this is also alpha. So the second angle for this cosine inverse of negative 3/5 is going to be pi plus alpha. Well, what's alpha? Alpha is going to be pi minus this 2.2143. So my second angle is going to be pi plus alpha, which is pi minus 2.2143, or you're going to get 2 pi minus the original 2.2143, which is basically going backwards. Remember, this is 2 pi. If I subtract 2 pi, not 0, but 2 pi, it will give me the correct angle, which will be 4.0689 radians. So you do have 3 solutions. You have the x equal to pi, which is 3.1416. You have the 2.2143 radians, and you had the 4.0689 radians.